Hello, and thank you to everyone joining us today for the Leader Online Seminar, Pipes Are Now Packets, What You Really Need to Know About QC Monitoring and Maintenance for IP. My name is Kristen Berkery, and I'd like to introduce Steve Holmes, Video Applications Engineer for Leader Instruments based in Los Angeles, California, USA.
Hey, Kristen, thank you.
And Kevin Salvidge, Sales Engineering Manager for Leader Europe, based in London, United Kingdom.
Hello there. Thanks for inviting us along today.
Well, congratulations, you've done it. You've deployed your first IP-based facility, and the flexibility that you hoped for over a traditional SDI-based infrastructure is being realized. But once the consultants, solutions architects, and network engineers have moved on, you're left with the reality of keeping your new facility operational. Your broadcast engineers have been brought up living and breathing SDI video. So has all the IP training sunk in? What test and measurement techniques should you be deploying in an IP-based facility? During the next 45 minutes or so, Steve and Kevin are going to highlight what you really need to know about QC monitoring and maintenance when it comes to your IP-based facility. Steve and Kevin have been involved in a number of video over IP deployments globally. So who better to provide an insight into what parameters you need to monitor and why? We'll be taking questions during the seminar, so I invite you to share your questions in the chat feature. Now, Steve and Kevin, I'll hand it over to you.
Thank you very much. So, Steve, why don't we just dive straight in there and show people what happens when it goes wrong?
Sounds good, Kevin. So the thing that people need to remember is that IP is just another I/O interface. It's just another way to get video, audio, and data to or from a switch. The how-to is what has changed. It's the tools that we need to use and how we need to use those tools are what have changed in doing this. Excuse me. Every device that we have when we're looking at this, waveform monitors, picture monitors, encoders, whatever we have, are going to react and show errors slightly differently. It's all based on how they turn around and build pictures. One of the unique things about IP that we have, though, is in a 1080i infrastructure, one IP packet is about 1/4 of a line of video. So when we take a IP hit and we lose a packet, it's incredibly devastating to what's going on in the system. This is one of the reasons that we've got the 2022-7 1-for-1 networks, where typically we have a red and a blue network within our facilities, is because we can't withstand that one packet drop. The other unique thing is that switches drop error packets. They do not pass them through the network. So some devices are going to break up randomly. Some devices have different errors all over the place, get stripes, get weird coloring. Then some devices just turn around and go off. In looking at this, one of the things that can happen, since the video packet that got dropped is 1/4 of a line, in some instances, you will get that entire line shift. So if you look at the picture that's up here, Lady Liberty got hit right in the middle, and everything from that point down shifted to the left by that 1/4 packet. And everything from there to the bottom of the frame is going to look like that. So that's one of the unique things about this IP is the hits can be incredibly devastating. Some devices are going to break up with just random lines all over the video due to that drop packet. Some devices may give you these funky looking errors where they get this color rainbow all through the picture. Some devices are going to turn around and just go absolutely black from the point of where the hit is to the bottom of the video frame till you get a reset and you start a brand new frame.
Right. So we've seen the impact that drop packets can have. How do we start investigating what might be causing, these issues?
It's a great question, Kevin. So one of the unique things is most of us are walking into this IP in a piecemeal manner. We're either starting greenfield so that we can learn it, or we're just making this section of my network an IP and working out from then. So the unique thing about 2110 is the timing information has been removed from the underlying hardware layer in the distribution, and it's an asynchronous distribution. So IP and IP switches are asynchronous by nature. We still have to make sure that our video itself is still frame accurate. So we need to be in our receiver at the same place we are in the camera when all's said and done. And we need to be able to do this after we go through an asynchronous transport mechanism. The intermediate IP distribution network, being asynchronous, does have the problem with possibility of packet jitter, some latency, and potentially long or video and audio delays. So we need to look at this stuff and be able to react to these and make sure everything within our system is working correctly. So we have changed, and we've got some major changes that we have applied to this. And one is, removing that underlying excuse me, my gosh, reference of the sources and the single signal distribution here. So in SDI, we put everything on the same cable. We had our vertical data, we had our picture data, we had the horizontal interval with the audio in it, and we put all of that on one coax. Where the coax went, all of that data went with it. The timing information was built into that, and everything went through just fine. So when we send a field or frame of video, everything went with it. In IP transmission, it started out with 2022-6. All we did in 2022-6 was we just encapsulated that entire amount of data, put it into a RTP multicast, and sent it on. But does not have the underlying flexibility that 2110 has, that it offers us. So in 2110, we break everything up. We send the active portion of the video as one RTP multicast flow. We typically call that our -20 flow. The horizontal information with the audio extracted out of that is sent as a -30 flow. The vertical interval data then is sent as a -40 flow. These three flows are typically on the same fiber, but they don't necessarily have to be on the same fiber. They are three distinct multicasts as we go through our system here. So we've got our video with its header and its payload. We have the audio with its payload, with its header and payload. And then we have our data as we go through this. And we look for these three different pieces to be able to put it back together. One of the unique advantages of having these as three separate flows or three separate entities is if you think about sports, and a typical sports venue will typically have around 20 cameras or more on the sports venue, looking at, if it's a baseball game, looking at the field or whatever it may be. But then you've got the talent that is talking over that, and they're switching any number of those cameras underneath of them. By having these as three distinct individual flows, it makes managing that a lot easier. We don't have to embed, de-embed, embed, de-embed the audio every time we want to do something and do this. So the flexibility of being able to do this is much greater in what we're doing here. So we've just kind of, to break the ice here, we've got a little bit of a poll question for you. And looking at what's going on here, where is my VPID located within a 2110 system? We're going to put up a little poll question for you here and ask you to answer that. So if you would, pick your answer. Let's see what we've got going here.
So while they're looking at that, Steve, I'm old enough to remember joining this industry when we had a video router, we had an audio router, and a data router. Haven't we just sort of gone full circle, but just changed the infrastructure that we're moving the data across it on?
Yes, they're all in one router now that we have. So they transverse the same exact piece of equipment. So let's see how we did here in our poll. So if we look at our poll here,
We've got a pretty even split.
the answer is it's in the ants stream. So anything that would be in the vertical interval actually now is pulled out and is placed in the ancillary stream. So things like VPID, your captions, all of that data, any of the time code information that would be up in the vertical interval on a line is placed in the -40 ancillary data stream. And it does need to be remarried at some point with that video, but that's where all of this exists.
Right. So right at the beginning, you said that IP is just another I/O interface, a way to get the video, audio, and data to and from the switch. So as this has changed compared to SDI video, what tools do we need here to monitor these IP systems?
Well, let's go back and kind of look at the whole evolution that we've gone through. In analog, if you think about the analog to SDI change, in analog video, we could just take our oscilloscope, hang our oscilloscope on the end of the video coax, and we could look at it. We could see the waveform, we could see the amplitude, we could see what's going on. We had to come up with ways within SDI to take the 10 bits of data that make pixel, put those together, put those pixels on the screen to either make a waveform or to make a picture so we could actually see where we were. Within analog audio, we could put an oscilloscope on the audio and literally see the waveform and look at the amplitude and see things. We had to figure out how to grab that audio channel out of the horizontal interval, turn around and make a audio waveform out of it, and how to represent that audio waveform on the screen. So SDI allowed us to carry all of that together within that, but we need to make new tool sets and new ways were created to turn around and look at it. Well, we've done it again. We've moved everything around. We've put it all on IP, on an IP multicast, but not just IP, but 3 different multicasts. multicast flows. So we need to be able to find and make tools, new tool sets, to be able to look at the video, the audio, the data, and the captions that may be within that data, and make these things visible so that we could see them. We still need to make them look like a video waveform. We still need to look like audio bars, and we still need to be able to throw captions up on the screen so that we can see what's going on and how we're doing this. So this brings up kind of what we've had in the past, engineering versus day-to-day work. They're two completely different avenues that we need to deal with. In engineering and IP troubleshooting, we need to turn around and have a tool set that will allow us to go down and look at the packet layer, look at the IP flows that are coming in, look at packet jitter, look at the PTP timing that puts all of this stuff together, look at buffer modeling, look at the 2022-7, which is that one-for-one transmission that we would have with a red and a blue network because of how devastating the errors are, and be able to look at this. But that's not what we need for everyday operations. We need to keep everyday operations looking pretty much like they do today. The operator still needs to see a waveform. He still needs to be able to see a vector scope. He needs to be able to see captions are transversing the system. Probably in some cases, we're going to have to look at SCT 104 tags and make sure that we can insert caption or commercials where they need to be done, audio loudness, and since we are converting from SDI to IP, we need to be able to see those conversions in a lot of cases right next to each other. So we've got conventional status displays that we've used forever and looking at things. So, you know, we're used to looking at CRC errors, TRS positioning, TRS code errors, line number errors, looking at the physical layer in our SDI, looking at I patterns to know that our SDI transmitter is performing how it should. It's going to be able to get through the system, looking at how open our eye is and the jitter that we have on the system to make sure it is recoverable at the end of the coax. Be able to look at the jitter output, look at timing information so that status eye and jitter timing are used to measure the integrity of that SDI signal. In IP, instead of looking at all of these CRC, TRS positions and look at this stuff, we're going to end up looking at the data that's coming in the door to make sure that we have our dash 20 flow, we have our dash 30 flow coming in, our PTP is here with us, and do we have any errors coming in? We can see the bandwidth on both of the two links and get an overall picture of what is coming into the scope for us and be able to monitor these packets. But we need to be able to take this much deeper. And one of the things we need to do in IP is look for signatures, be able to see how the video packets are coming in, the audio packets are coming in, and they will build a signature that you need to get used to looking at. You'll see a peak-to-peak response of how late packets are coming in and how early packets are coming in, and they will build this signature that you need to be able to look at and have all of the data of that same information coming in the door. We can also take this signature, which is really nice, and run it out from looking at the last 2 minutes to looking at the last 72 hours. And then you can also take this data and dump it on a USB stick as a CSV file and actually look at all of these statistics for those lengths of time if you need to go around and search for something that may have happened in the past.
I was going to say, So obviously the arrival of the packets are critical. But I've also heard this term PCAP mentioned, where people say, right, I'm now looking almost like at the raw data, I'm looking at it at a packet level. What are the tools that we use to capture this? How, why do we need this, Steve?
Yes. Great question, Kevin. So a PCAP is a piece of software that is going to grab the data, the IP data coming into your waveform monitor, because this is typically where you're going to do it. You can do it on a computer, but it typically doesn't have a 25 gig interface to be able to get that in real time and be able to look at that. So PCAP is an abbreviation of packet capture. So if you're dealing with a trouble with a vendor, they quite often ask for a PCAP so that they can capture the data and actually see what is being delivered in this. And we have the ability to be able to grab a PCAP from either port 1, your red network, or your blue network, or the control network, and send that off or examine it yourself. Or we can pre-filter it. If you just want to see the PTP, the timing data, we can turn the pre-filter on and then turn around and just look at that. We also, on our network analyzer, have the ability, since it's looking at many flows of traffic in parallel, basically looking at everything that's coming in the house or leaving the house, we can turn around and pick which entities we would like to capture and how we would like the capture set up.
Right. So, packet arrival is critical. You also mentioned that 2110, the timing information has been removed from the underlying hardware and the distribution is asynchronous. Isn't that just asking for trouble?
Not really. The industry has come up with ways to be able to do this and deal with those asynchronous issues. So with PTP, it's been used for years for being able to timestamp data down to the nanosecond. It's used on stock trades so that when you turn around and you hit a buy, it's got a timestamp that's down to the nanosecond level of when that buy was initiated. It's used in our cell phone networks when we turn around and transfer from cell tower to cell tower to cell tower. That's all done using PTP. So PTP sends a sync, which is just the time at this instant, GPS time at this instant, to the receiver. And we call receivers followers because they're going to follow the grandmaster's time. And then the receiver is going to be able to know what his time is, the time that you sent him. He's going to turn around and send the data back to the grandmaster. The grandmaster will timestamp that and send all of that data back to the follower. So now the follower has the time that the grandmaster sent, and when it was received, it has the time that it sent back to the grandmaster and when the grandmaster received that. So if we actually subtract the T2 time from the T1 time and then subtract the T4 time from the T3 time, add those two together, divide them by 2, we have an average of what the video latency is, and we can subtract that video latency and have an average value of what the network is actually doing here. Then we can turn around and show this data looking at the PTP coming in and actually look at those variances of those packets coming by, or we can actually look at the time values that are inside of those packets as they come by and the differences that the follower is changing to compensate for those underlying issues that we're doing. You can kind of think about it as looking at a road here. One of the unique things we need to keep in mind is that the T2 minus T1 coming from the Grandmaster to the follower is also coming with all of the video, audio, and data coming to us. The answers back from the follower back to the Grandmaster typically don't have any traffic or very little traffic going back the other direction. So it's not uncommon that the T2 minus T1 from the Grandmaster to the follower may be a little more delayed than the data going from the follower back to the Grandmaster. We need to keep an eye on these two values and make sure they are incredibly close to each other. Because if the value of the T2 minus T1 gets too high, it's telling us that our network is getting bogged down, and we need to start looking at our switch and the loading of things within our switch. So we can look at those delay times. We can see what's happening on both ports, on our red network, our blue network, and actually look at those delays and all of the sync messages that are coming out of the PTP. Be able to see who our Grandmaster is on both ports and what domain that we are looking at, which is just a numeric value assigned to this particular network, and look at all of those timing pieces and actually be able to graph those out. They should, like the packet flows, should have a nice, fairly clean signature of what's actually going on.
So is it a fair point to say that this is one of the first places to look, is your PTP timing?
Yes.
When you start trying to analyze what's gone wrong, because if your reference isn't right, you've built your house on sand.
Yes, most definitely.
So I think that's going to be compounded, if I understand this correctly, because obviously 2110-20, the video stream, it's only the active pixels. Now, from those of us who remember analog video and SDI video, we had blanking in that kind of was the precursor to the active picture. Where is the active picture offset? How do we know it's in the right place? You know, I'm assuming we need tools to find this out as well, Steve.
We definitely do. So one of the unique things about PTP is, like you said, looking at those offsets. PTP itself starts typically at the same exact place Black and Burst starts at, or tri-level sync, at line 0, pixel 0, right at the beginning of the vertical interval, so that it is in time with where Black is, so we can put things back together and have a reference that is the same between the two. So we can look at and see that our PTP is perfectly in sync with our house, because I'm looking at in this case, this was looking at tri-level coming in at 1920 by 1080 and looking at the PTP and seeing what the offset was between those two. So PTP to Black Burst phase. The other thing we need to look at then is the offset of the video, because our video starts at its 1080i, 21 lines later in the entire frame here to get the active raster. We need to make sure that we are that same offset. Now, it may or may not happen exactly at 21 lines, but it's going to be somewhere around 21 lines, typically plus or minus 1 line, and looking at it, and we can actually see that vertical offset and see where it is. It would be 42 lines offset if you're 1080p or if you're 4K. And this is now looking at the RTP to PTP phase reference. So the RTP would be that packet holder that's holding all of that video in that packet and making sure we're perfectly in time. And that way my raster is perfectly in time with my house raster. If I've got some SDI in there, we're at the same exact place and time. The other thing we need to look at is also look at what we call the FPT, first packet time. So within that RTP frame, where is that first packet of video? And it, in this case, is exactly 21 lines out and starting our video at the same exact point that our video starts at SDI. So we can look at it in a time chart and see where that first packet actually is. And then we also have tools where we can turn around and graph that timing out to make sure, since that is the first packet of video, and we need that to start consistently, where we're at in looking at that. We can also take that RTP phase to make sure the RTP packets are in the proper placement and actually graph those out for the video, for the audio, and for the ANTS data, and look at those over time.
So would it be fair to say, Steve, if you remember anything from this, if you're looking at timing, interlaced is 21 lines, progressive is 42 lines. Get those numbers, make sure they stick, because that's a great place to start looking to see if the active picture is in the right location.
Absolutely, absolutely. So, you know, the timing comparison of the first packet time, being able to see that and look at things and start thinking about what to look for when the picture is either not being presented, or the picture is breaking up, or the picture's half torn, you only see part of the picture. And those are indications that you're running out of buffer room, that the data is coming in too late and you don't have enough buffer to be able to see those. One of the features that we've got, which is akin to taking a regular waveform monitor and turning on external reference, because most of the time inside the house, we've got the external reference turned on to make sure that everything we're looking at is in time with the house and it's perfectly synced. But if it's all broken up and too far off the screen, we can turn off external reference and just lock locally so that now we can troubleshoot it and bring it in. Well, we've got the same features within the waveform monitors to be able to do that. And that's our timestamp mode. If you have timestamp mode on, it's akin to having the waveform monitor on external reference. We are actually looking at PTP to put all this data together. And most monitors don't do anything with PTP. Video walls don't do anything with PTP. So they generally, on timing issues, don't have any issue building a picture and putting the picture up on the screen. But when you get to something that needs to be able to process the video, because now it needs to put the video together with the audio and with the ANTS data, they look at PTP. They are synced to PTP, and you'll start seeing issues there where you don't see it on a monitor, because the monitor has the ability to basically free run and just FIFO the data as it's coming in the door. So we can do the same thing by turning the timestamp mode off, and will be exactly like the monitor. You can see the data, and now you can have the data on the screen and be able to troubleshoot and see where things are going with this.
Oh,
So
this is quite interesting, because I had a customer who, they called me up saying that they've got one service, they can't see the picture. Yet we went into the status and it said there was network activity there. And as soon as we switched this mode over, the picture appeared. Then they traced it back to a gateway and found out that somebody hadn't done a software update on that gateway. They've done the other 12, but not that one. And as soon as they did the update, the picture appeared, and it was just purely outside the timing window. So it strikes me here again, it's using that kind of SDI technique of switching off and on the reference to find out if you've got the picture there and it's just not timed correctly.
Absolutely.
So, so we mentioned earlier, obviously SDI video has the video payload ID that contains a wealth of information relating to the video signal. As you saw from our earlier question, we asked, where does that exist? Because it doesn't exist in the -20 stream. We've only got the active video. So if you can only see the -20 stream, how do you know what video you've got? Because I'm looking at this and thinking, where's the information gone? Yet here on the screen, Steve, you've got it telling me that the format is 1920 by 1080. You've got a frame rate. How's it doing it?
Well, there's two ways that it's actually done. One is just looking at mathematical statistics and trying to figure it out. The other way is that data is actually sent to the waveform monitor in what would be a file that says this is what it is your turnaround and you're looking at. So the VPID can be sent, and we can look at what's happening within the waveform monitor by looking at the -40 flow and pull that data in and look at it. Or we can look at this thing that's called an STP file that we'll talk about in just a little bit and be able to look at it. So there's a couple of different ways, but you got to make sure that they agree with each other and they're doing the same thing. So we can look at the -40 VPID, and the video payload ID is still the same thing it was in SDI. It's just coming on a separate IP flow coming to the waveform monitor.
But the great thing there, Steve, if you just go back, that picture for SDI and IP, that information, the layout and the format look the same. So for an operator coming from an SDI world and now having IP signals, that shouldn't scare them, should it?
Yes.
So we've been using certain terms in here, and basically there is a whole new vocabulary, isn't there, within this world of IP that we're now embarking on. Maybe you can give us a quick heads up on some of the kind of key ones that we should be looking out for or expecting our engineering staff to start commenting on.
Okay. So in SDI, we are used to looking at CRC errors at a receiver location to know that packets are being dropped because the I pattern is completely gone, typically at the end of the cable run. And then the TRS, the EAV, SAV locations, their code values, line numbers, would look at all of those entities. In IP, we're going to be looking at that packet arrival time that in the previous slide was a nice, clean set of min and max values. Here's one that's definitely in severe trouble. And this is what it would start looking like. You'd start having these packets coming in really late, packets coming in super early, almost slamming the graph down to 0. And look at these differences in these packet delays coming in, letting you know something is seriously wrong with either the switch, or in a lot of cases, it's the device that's making the IP, a playout server or a gateway. But when we see the errors, what you're going to see are these red spikes in here that are RTP errors. And RTP has a counter in it, and it's much like MPEG when we had continuity counts in MPEG. and we could look at a miscount of the continuity count and know that we've dropped a packet in MPEG. This RTP counter is exactly the same thing, letting us know that we have dropped a packet and we have a misstep in that packet count. So it would just give us a packet 1, packet 2, packet 3, packet 7. Oops, I've got a miscount, and that packet's gone because the switch is going to throw that packet away and be able to look at that. So we can look at the packet arrival time here and know what the existing signature should look like, and see all of these late spikes coming in to actually see these different things.
So my next question was going to be is, these must appear in event log somewhere.
Yes. So we
And-
have an event log, just like we would for anything else. These are going to give you the events and give you all of the pieces now for IP as well as SDI, depending on which one you're looking at and which input you're looking at. Are you looking at an IP input or are you looking at an SDI input? And then you can get the event log for each as we look through it.
Do I also understand correctly, just going back, Steve, that you can also on the device set the event log time, so it's using PTP? So you've
Yes,
got
you can.
that as a reference as well, if you're trying to fault find across multiple devices in a facility.
Yes, you can turn around and set the event time to time of day. You can set it to PTP, or you can turn around and set it to the time that's actually on the video itself if you happen to have time code running.
Right, so that's great. Right, so we've got our IP network operating. That's kind of the engineering side of it. As far as I'm aware, our customers are still watching pictures. And to be honest, they don't really care whether it's the latest state-of-the-art IP facility or it's some guy in an industrial estate in a lockup that's broadcasting this stuff. Pictures are what engage, that's what we look at. I presume we're looking at a similar set of tools that we had in SDI for analysing the picture quality.
Exactly, and that's one of the statements I was making for operational monitoring. We still need to look at pictures. We still need to look at waveforms. We still need to look at vectors and be able to see those. And in this case, you can actually see where the video has come in here on my SDI, has gone through a gateway, been converted to IP. I can see that data after that gateway to make sure it's exactly as the same that's coming through. I could look at it some other place within my network and then look at it if it was being converted right back to SDI and make sure that coming in from SDI, going all the way through my network, coming back out as SDI, that nothing has changed any aspect of that video and how we turn around and look at this. So we can see those pieces all the way through what's going on here. Also, we can turn around and put up a conventional quad display, but kind of on steroids here, if you will, that I can see my video, my vector scope, picture, and status for my SDI. I can see my waveform, picture, vector scope, and status now for my IP layer here, and actually see the differences between what I'd be looking at in SDI and IP of the same exact feed coming into a gateway, coming out of a gateway. Because let's face it, in the early days, we're going to be dealing with a lot of SDI that's coming in, being converted to IP and transverse in our network as IP, and we have the ability to turn around and look at both of these. We can look at them as waveforms next to each other with a little picture thumbnail, so we know that we are looking at the same exact data and be able to see that and see what's going on both my SDI A, SDI, and my IP coming in the B input. And from an operational standpoint, one of the major things here is we can also look at, in a true hybrid operation, be able to see that, okay, coming into my gateway, I've got my captions. Coming out of my gateway, oops, something's happened. My captions have disappeared. I don't need to go digging into a ton of data because as the operator, that's not my job. That's the engineer's job. I just need to be able to tell now engineering, hey, we got an issue here. It's missing. And I can see it the same way I've seen it forever. We can have multiple things on if you want to be able to see a Luma waveform or see a waveform at the same time you're looking at the picture and see that same data that's missing here.
So you just use the term there, true hybrid. So that's the ability to look at both SDI and IP simultaneously on the same single display.
Yes, and to be able to have more than just 4 different things up on the screen. We can have hundreds of individual pieces of data on the waveform monitor screen to do the job that you need to do so that you can see it all simultaneously and next to each other.
Right.
So up to this point, we've got another quick poll question that would love to ask you guys here. We talked a little bit earlier about the VPID data, but now closed captions, like in that example where closed captions didn't come through the network. How are the captions being sent across the system? So let's take a vote here. Let's see what you guys think.
Obviously, on the one previously, they're not being sent anywhere because they're not there. But, if they were there, where would they be?
Where do I need to go look to see if they're there or not? Okay, why don't we take a look at what our answers were on these poll questions.
They're learning.
90% of you got it right. It's sitting right here in our -40 display. And that's where our captions are going to be, because captions are sent typically on line 9 in the vertical interval in 1080p, and they're turned around and pulled out, sent on that -40 stream. But we still have to be able to overlay them in time again with where we are going here.
I was just going to ask you, Steve, we've been talking about video, we've been talking about captions, but I'm sure there's some audio guys out there saying, well, hold on a minute. This is another one of those video presentations that audio doesn't exist.
Well,
how can we use this for audio? Because obviously we know that the audio, the -30 or 31 stream, again, is separate. It's not part of the video.
yes. So the -30 flow, our audio, is another multicast. We do need to make sure it's coming through and it is coming through correctly. So in that stream here, we have the ability to put up, again, what's coming into the gateway versus what's coming through the IP. And we're looking at a typical 5.1 display coming in off of our SDI here, but somehow our surround channels got nipped off, because in some underlying pieces for some pieces of equipment, they're still sort of treating it like IP. They're still looking at group 1, group 2, group 3, and group 4. Some IP pieces don't look at it that way, but apparently this gateway does, because it stripped off the last 4 channels and did not send them through the system. So we have the ability to be able to put a list of the overview of the ANTS data up on the screen and be able to look at things side by side. So here's my ANTS packets coming off of my SDI, which are actually in the vertical interval. Here's my ANTS data that's coming in that would be in my -40 flow. And we want to make sure that in this case, you can actually see that my VPID didn't make it through the system. My 708 with my 608 writing inside of it didn't make it through the system, but yet they were coming into the gateway that was making all this video. And the gateway just wasn't configured correctly. We can also look at things like, is the video, so now we can go to the magic decoder ring and actually look at the VPID and look at byte 1, byte 2, byte 3, byte 4, and see it in English readable text, seeing that my SDI was coming in as progressive, but that in the -40 stream coming in got marked as interlaced. And so that it did not come in correctly. The waveform monitor can typically take that and actually display it correctly, because it'll look at it and say, no, that's definitely not interlaced. Here, I'll put it up on the screen for you, but I'm going to generate an error so that you know that there's something wrong, and you can look at it and actually see what it is really quick.
So Steve, there's a lot of information here. Call me naive, but a quad split display is not going to be enough to be able to demonstrate, to be able to analyze this simultaneously.
In most cases, you're absolutely correct. So that's one of the beautiful things of having a display that you can put in there what you want, so that you can look at all of the different aspects of the IP coming in. We can look at the bandwidths, we can look at those timing issues, we can look at the RTP flows, see the errors that are coming in, see huge changes in how the flow should have looked like to what the flow is looking like when it got switched to a different source, and actually see those gaps in data. We can have the timing up on the screen, have a waveform on the screen, have the picture data with captions, with SCTE 104 markers overlaid when they come through, and have multiple things on the screen at the same exact time, and be able to look at those entities that have happened and correlate them back to when things actually went wrong on us.
Yeah, that's really useful. Right. One last question that I get asked frequently, and this is now because of the introduction of orchestration and control systems above, NMOS, and the control of devices using what's known as a session description protocol data, or SDP file. We've obviously established earlier that a lot of the ancillary data can be contained within the -40 stream, but I'm understanding there are devices out there that will automatically generate this ancillary data and put it in the session description protocol data stream. That just sounds like another avenue where we could start chasing our tail.
It is, but it's needed, since we're not putting it all in one place. We need to be able to describe the video and what to look for, how to look at that video coming in. We need to be able to describe the audio. We need to be able to describe the ancillary data. What multicast is it on? Who's the sender? Where is it going? What's in it? So NMOS has given us those tools with, we are going to register each one of those pieces of data by the sender. And now when you push source, we have that data that the sender sent to the registry server. You send destination, okay, that's who I'm going to send it to. And now you say take, and now you send that data to that receiver, which is now going to tell it, okay, that's the multicast you need to go look at. And this is what's in that multicast, and this is how you look at that thing in that session description protocol or STP file. It's just a text file that is sent to the receiver that allows people to look at this. So we've got different pieces of data in here that we can turn around and look at. And one of the biggest things is, looking at, okay, it's 422, 1920 by 1080, it's 10 bits, it's at 50 hertz, and colorimetry is 709, it's SDR, it's not HDR, and it's coming in as a 2110-20 profile. And gives me things for both the primary and the secondary, the red and the blue network, exactly what IP addresses to look at. Do the same thing for the audio, how many channels we get, what IP, what multicasts to look at, and then also for this data flow. So we can turn around and break these down and look at them. And right now, this is probably one of the biggest things, because some of these STP files get munched before they get sent down, and you get the wrong frame rate, you get the wrong picture height, or something else may be incorrect in them. But it's just a text file, and after you look at it a few times, it becomes fairly easy to actually look through and actually read what's happening. One of the tools we have is the ability to look at that data coming in the door and actually present those STP files. And you'll notice up here real quick that we've got a 200 code right here. It says okay. It's sent as HTTP data, so it's going to look like what you get on a web server or a web page. We've all seen a 400 code or a 401 when the data is wrong or you can't reach the site. Well, you're going to get the same things here. If the data is munched and doesn't parse out correctly, you're going to get a 400 code. If the data is absolutely perfect, you will get a 200 code, letting you know at least the data structure is correct. The information in it may not be, but the data structure is absolutely correct. So we can look at all of those things and be able to look at those things. And like you said, look at, hey, it's coming in interlace, but you're stamping it as progressive. That's going to screw up devices down the line that are now going to look at this as a progressive stream when it may not be. So we have the ability to turn around and look at this in multiple formats, multiple ways, and actually hard code to say, hey, it has to be this format. If it's not this format, alarm, or turn off the format alarming if you're jumping through many different formats coming in. But if within your facility, you are 1080i or 720, and that's what you always expect, you can turn around, turn on this alarming feature. And if something else comes up, we will turn around and let you know. And again, be able to look at what the differences are between these two and see why have I got this error and what's not correct in this. Kevin?
That's great. So obviously we've been talking now. I think we have had some questions come in, haven't we, Kristen?
Yes, we have. I received a good question here. Let me scroll down to it. One moment, please. Is there any way to check if the video to audio timing and video to ancillary timing of SDI source is maintained over IP?
There are. We didn't have time for it in here to get into it in a lot of detail, but there are timing screens within the waveform monitors, especially within the LV5600, 7600, that will tell you the timing coming in of the video, the timing coming in of the audio, and the timing coming in of the ancillary data. And you can look at those RTP timestamps to make sure they are absolutely correct. One other feature we have is, yes, you can have audio be time-stamped correctly, but did the audio actually get placed within that timestamp correctly? So our AV delay test that we have for SDI actually transverses our IP network so that we can actually do raw video audio with a pop flash type sequence and actually look at that and verify through all of the gateways, the encapsulation, de-encapsulations, even if there's encode and decode in between there, and verify that the audio is within looking at the same exact time of the, tell you exactly how many milliseconds advanced or delayed it is next to your audio.
That tool we're finding is now really useful, especially for customers who maybe have got UHD services that they're converting to HD, or maybe even HDR that they're converting to SDR. These conversion processes take time. And when that signal leaves each device, it gets a new timestamp. Whereas, fortunately, the audio will just go straight through. So you can use the audio to work out what the potential propagation delay are through those various conversion products.
Okay, I do have another really good question here. We know where to start when looking for issues in SDI. What's the ABC of where you start for IP?
Well, I think I hinted at that, didn't I, Steve, earlier on when it said PTP is a good place to start.
PTP and the IP status page are the entities that you're looking for there, and are the signatures put out by those entities correct? You got to have them coming in to be able to, have them. Do you have the -20 flow, the -30 flow, the -40 flow? Are they coming in the door? And the min-max interpacket arrival time, does it have the proper signature that you normally have when everything's working correctly in your system? That's a good place to start.
If you've got them there, then you can start diving deeper and then start looking at the interpacket arrival time, then the first packet arrival time and those timing charts. But I've seen it where the device says that it's connected to a multicast flow, yet there's no data on the stream because basically the session description protocol file has sent it to a stream that doesn't have any data in it.
Yep.
So you're saying I've got no picture. Well, that's because there is no picture. There's no video data on that stream. So it's hopefully what we've discussed today is, stuff that we found now over the last 4 or 5 years as we've, as a test and measurement manufacturer, we sort of sit as the referee in some of these discussions. With SDI, it was simple. You took a cable, you plugged it in and a picture appeared. With IP, we're not plugging them direct. We're going through another device or maybe multiple devices. So we have to kind of step our way through, making sure that that picture is, or that data is being transferred within the correct timing windows.
Yep. And we need to be able to have simple tools for the typical user that he's used to looking and easily set up those screens. If you want 4 different instruments on the screen, great. If you want 6 instruments on the screen, great. If you want 8 instruments on the screen, great. We have the ability to configure those, size those, and place them where you need to do it for the job you are currently doing. Save those off as a simple preset.
And the ability to compare SDI to IP.
Yes.
Even the facilities that say we're an IP facility, you go in there, you'll find some SDI sources floating around.
Oh, yes.
You'll find a black and burst reference or tri-level sync still inside that building. The gateway products are now very good, but most of the issues we see are as this video and audio and data transitions from one timing plane to another. We're going from black and burst tri-level sync into a world of PTP. And if they're not, those references aren't coming from the same device, you can have some challenges on your hands and you can be chasing your tail. So having tools that connect to both black and burst, PTP, SDI and the IP flows is going to give you a fighting chance of finding out where that signal has gone awry and why you've not got pictures or you've not got captions on your MCR layout.
And being able to look at those SDP files, because there's still a lot of finger boning that happens in today's world. Eventually we'll get away from it, but right now a lot of the human interface servers that interface to this NMOS still have a lot of things that you manually have to put in, and there's sometimes errors when you have to put things in manually, and be able to see that SDP file and see that, oops, okay, that didn't come down configured correctly. So a lot of things. So we have run over the time just a touch, so I want to apologize for that, folks, but thank you for sticking in there and listening to us today.
Thank you so much, Steve and Kevin. The presentation slides are available for download using the link in the chat. We'll have that there in just a moment. And we also have a QR code that you can scan. We'll share that in a moment as well. The replay of this event will be available shortly, so please watch your email inbox. We will be sending out an invite for you to check out the replay. On behalf of everyone at Leader and our hosts, Steve and Kevin, I want to thank all of you for joining us today for the Leader Seminar, Pipes Are Now Packets. We hope you have a great rest of your day. Gentlemen, would you like to say any final words?
If you have any questions, and you're probably going to go away from this and then suddenly go, I didn't ask that. Here are our numbers. Steve, if you're based in the Americas, and I'm based here in Europe, out of London, give us a call, send us an email, and we'll explain and try and answer your questions.
Definitely, definitely. We're here for you, and want to thank you for attending the presentation. And as you download the presentation and you look back through it, again, if you have any questions, send us an email, give us a call. We're here to help.
And so Steve said, thank you for joining us today.
Take care, everybody.